Hi everyone. Today I will talk about how we can use AI and machine learning tools to power wheat seed variety recommendation for my business. So this is going to be an improvement in the customer experience because the customers will be able to get accurate recommendations for the seed varieties. It's a pretty complicated decision for them. And if an AI tool can look into various factors and give a good recommendation, that could really drive a good customer experience. And it'll also help my company to drive sales from the e-commerce portal. Let's start. So the project's objective would be in this project, we will be developing an AI-powered recommendation system for wheat seed varieties on Bayer's e-commerce portal. This system will improve customer efficiency and experience by offering personalized product suggestions based on the past behaviors and data-driven insights. And I'll talk about more on that obviously in detail soon. So the context is currently the customer face challenges in discovering the right seed varieties that meet their specific needs. With numerous seed variety options available, it can be difficult to navigate, leading to suboptimal choices or missed opportunity for buyer. So, kind of to elaborate on this, uh, as a farmer, when you are selecting a particular wheat variety or a variety to plant, you're thinking about a lot of factors like what type of season you're in, how late are you in the season, what kind of field you have, is it good for a certain variety versus another. Wheat has different seasons, so that could also impact, like it is it a winter wheat or a summer wheat or a spring wheat. And then there's a lot more of things to consider, and you might have spent some time also optimizing your farming practices for certain type of varieties. So we can take all of that into account to give you a great recommendation on what seed varieties would work for you. Even for the newer varieties that you have not laid your hands on ever, this model will be able to then look at all of these data points and say, this is a new variety, but this is very close to this particular variety, or this could perform like this in your use case. So we can take all of that into account through an AI ML driven recommendation model. So by leveraging AI, we aim to streamline the product discovery process, ensuring customers receive tailored recommendations that fit their farming requirements, ultimately driving customer satisfaction and increasing sales conversions. So obviously, if every organization's goal is to improve customer experience and to then drive their own sales and profitability based on that. So that's from our intrinsic perspective, everything is really driven towards improving profitability. Um, Agenda. This presentation will walk through the machine learning project development process, and that's our assignment. And this is based on the CRISP DM framework to explore how this recommendation system will be built, validated, and deployed in production environment. So this will go through various stages. So we'll start with opportunity evaluation, then we will go through business understanding, then validation plan, then ML system design, then risks in production. We'll talk about that, and then we will talk about in the concluding slide about summary and the next steps. So let's dive into opportunity evaluation. That's the first stage of our CRISP DM process. So the problem statement we have is customers on Bayer e-commerce portals struggle to find the right wheat seed varieties, leading to suboptimal purchases and missed revenue opportunities. I mean, we do provide customers with different traits and features of a particular variety, and customers can go through it. It's not very easy still to, there are hundreds of varieties and they have different like levels of, for example, yield that they could provide in a different season versus how late you're in the season, how's your field and all that. So it's not very easy for customer to then even though they have good detail on a variety, to come up with a great decision. There is still a lot left to guess, I guess, because it's just not easy for a human to think about all those parameters and in an optimal way. So, so why AI ML recommendations? An AI recommendation system can enhance product discovery by suggesting relevant seed varieties based on customer preferences, browsing history, and farming needs. Now, opportunity criteria, uh, business impact, boost sales by improving product relevance and reducing cart abandonment. Um, so if we can if we can help the customer uh, find a great recommendation and they have a higher confidence, there's a lower chance that they will, they will not complete the process of purchase. A lot of times customers start the process, and by the time they come to their cart, they're still not very sure, and then they think that maybe I should do some more research, and I'm just too confused, maybe I should come back later, and that's when we lose an opportunity to sell a product. Then feasibility, existing customer data and product information make this product project viable with current technology. Strategic fit aligns with Baer's goal to enhancing customer experience through digital innovation. Now let's go to the next phase, which is business understanding. The current state. Currently, Bayer's e-commerce platform lacks personalized recommendations, leaving customers to manually search for wheat seed varieties. I mean, we could build some heuristics and give them some recommendations based on that, but again, it's still not, I would say, not a great recommendation given this technology. How we can use this to give come up with a much better recommendation. Some of the rules that we built in heuristics, we have to update them if there's a new variety. We're not too sure about the rules, and how those will impact the recommendation, and also it's just too complicated to get it right. Success metrics. So let's talk about objective actually first. The objective would be to enhance customer satisfaction and sales by providing personalized seed variety recommendations based on customer behavior, preferences, and farming requirements. Success metrics. There are two outcome metrics and output metrics. Outcome metrics would be more for business. So this is increase in customer satisfaction measured through post-purchase surveys. And then another one that we can track is increase in overall sales and average order value driven by recommendation interactions. An output metric really around more around our ML solution. So this will tell us how good our solution is performing really. So this will tell us this can be tracked through click-through rate on the recommended products, and then conversion rate from the recommended products to actual sales. And then relevant factors, user demographics, example region, farm size, past purchases. I can throw in a few more there, I guess, but let's go to product features. Those will be more around seed type, seasonality, compatibility with climate, compatibility with field, even what kind of planter you have. There are a lot of things. How much nitrogen are you planning to use? What is the pest pressure in your field? A lot of those factors can play into this. But these are the main ones we will kind of use for the purpose of this presentation. Data understanding. This is the next phase where we really try to understand the data that we have. So let's start with the data sources. We will leverage existing data sources, including customer data. So this is more available like internally, purchase history, browsing behavior, and demographic information. We generally have this data available internally. Product data is also available internally. So this is like detailed attributes of wheat seed varieties, type, seasonality, yield, performance, and all. We have that data because we've been doing a lot of either internal research on these varieties before these are commercialized, or we have this data because we've been selling these varieties for 2 or 3 years already. Then external data, the data that is not generally available directly internally. So we outsource this data. So this could be geographical and climate data relevant to farming conditions. we can go to different parties to get some of this data, like around field and all that. So we can use, for example, data from John Deere or some other, like manufacturers of the machinery, planting machinery. Their planters are really modernized, so they collect a lot of data around field when they've planted the seed in a previous season. They collect the data, so that we will know exactly what is the area of the field, what are the boundaries of the field, if there's a creek in between, what kind of soil is there. So a lot of data can be attained from there, and then we can also get climate data about what is the seasonality of and what rainfall, how much rainfall does it receive, and all that. Then let's talk about data quality and challenges. We will also review that in this particular phase of the project. So we will try to determine if the current data is sufficient or not, and we will see if there are any challenges. Challenges could be like there is missing data, so some gaps in historical customer behavior or incomplete demographic information. That could be there because, like I just mentioned, for example, if some customers are using more advanced planters versus some are not, so we might not get similar type of planting data about their field. So yeah, that could be categorized as missing data, for example. Then data silos. Data may be spread across different systems, requiring integration to create a unified data set for recommendations. And this could really happen in a large company like Bayer, because you could have data from um, like data is lying in different systems. There is like when we enrich the data, there could be different levels of enrichment in the data for the same type of customers or similar type of data. So all of that could impact, could be because there are data silos in within a large organization. Then initial insights. Preliminary exploration of the customer purchase data shows trends based on seasonality and geography. These will inform key features for the recommendation model. Validation plan. This is the next phase. User testing strategy. So we will implement a phased testing approach to validate the AI-powered recommendation system. Then pilot group, we will come up with a pilot group. A subset of frequent customers will be selected to test the recommendation engine. We will collect feedback on the relevance and usefulness of the recommendation. So generally, our farmers or customers that are more excited about new technologies and they're ready to try these new things. So they would also be interested sometimes in testing a recommendation engine. They work with us. They give us some time to go through each version and then check if the recommendation really makes sense to them. We can do some A/B testing and all of that there. Then metrics for validation. Recommendation accuracy, we will measure the percentage of recommendations clicked by users and whether they led to a purchase. Customer satisfaction, that could be another metric. We will assess through direct feedback and post purchase surveys to determine if the customer found the recommendation helpful. Conversion rate, we will track the percentage of the recommended products that result in a purchase to validate the model's impact on sales. Then feedback collection, customers will rate the quality of the recommendation through post-purchase surveys and in-app feedback prompts. We will track key engagement metrics like time spent interacting with the recommended products. Iterative refinement, feedback will be used to refine the recommendation engine by adjusting the algorithm, reweighting features, or incorporating additional data as needed.